Hey everyone, and welcome. So think about this. When you log into your bank or your email, how does that website really know it's you? And just as important, how do you know you aren't talking to some imposter? Today, we're going to dive deep into the world of digital identity and how we prove who we are online.
You know, it really all boils down to this one single massive question. In an unprotected network, which, let's be real, is basically the entire internet, anybody can pretend to be anyone else. This risk of impersonation, well, it's the fundamental problem we have to solve to do literally anything securely online.
So in this big, anonymous world, a server needs to be able to confirm the identity of every single client that asks for something. But can you imagine if every single server had to handle authentication for every little interaction? It'd be an absolute mess and incredibly inefficient. This huge security challenge led to the very first major solution, taking that burden off of individual servers. So here's the core of it, the fundamental challenge. We need a way to prove our identity without just shouting our password or other secrets across the network where any bad actor could just snatch them out of thin air. The first big solution to this whole puzzle wasn't designed for the wide open internet, but for a much smaller, closed-off, private environment.
And that brings us to Kerberos. I want you to think of it like the central security office for a huge corporate campus. It's a trusted third party, an authentication service that basically acts as the gatekeeper for an entire private network, or what it calls a realm. It was actually developed way back at MIT, and it pretty quickly became the gold standard for remote authentication inside these private realms. Its whole job is to be the trusted middleman, so individual clients and servers don't have to worry about it.
Okay, so here's the play-by-play. You prove who you are to that central server just once. That's it. In return, you get what's essentially a master ticket. Then you use that master ticket to get temporary little passes for each specific thing you need to access, like a printer or a file server. And the crucial part? Your password never has to be typed in again or sent over the network. It's brilliant.
And this really highlights the system's big trade-off. Kerberos is absolutely fantastic for building a fortress of trust inside a single organization, a single realm. But, and this is a big but, it requires every single user and every single server to be pre-registered with that one central authority. And that model just does not scale to the global internet. No way. This comparison really lays out why a totally different model was needed. Over on the left, you've got Kerberos, centralized trust for a private network, like your office. But for the public internet, we needed the model on the right, a distributed global web of trust. And that required a completely different kind of ID. Enter the X509 certificate. Seriously, if Kerberos gives you a corporate ID badge, an X509 certificate is your digital passport, recognized all over the world. It's the standard that's used in pretty much all network security, from that little padlock you see in your browser to secure email. Okay, so technically what it is a block of data that binds a public key, think of that as a digital mailbox slot that anyone can use to send you encrypted stuff, to an identity. But the most crucial part is that this whole block of data is digitally signed by a trusted third party, which is known as a certificate authority, or a CA. And if you break it down, it looks a whole lot like a real passport. It's got the owner's name, who issued it, an expiration date, and of course the owner's unique public key. But the most important part, the part that makes it all work, is the signature from the issuer. That's what verifies that all the other information is legit.
And this is the key to the entire system. That certificate authority, the CA, it acts just like a government passport office. Your web browser, Chrome, Firefox, whatever you use, comes with a pre-installed list, sometimes called a trust store, of hundreds of these CAs that it automatically trusts to issue valid digital passports. Now, these individual passports don't just exist in a vacuum. They're all part of this massive global system called the Public Key Infrastructure, or PKI. This is the whole shebang, the hardware, the software, the people, the policies, everything needed to manage the entire life of these digital certificates. So the logic is actually pretty straightforward, right? You trust a website certificate because it was signed by a CA that your browser trusts. This creates this giant web of trust that is the foundation for nearly all secure communication on the internet. It seems pretty solid.
But here's the critical question. The entire system, this whole beautiful web of trust, it all rests on the assumption that every single one of those hundreds of trusted CAs is secure and well managed. So what happens if one of them, just one, gets hacked?
And you know, this isn't just a theoretical question. The PKI system has failed in the real world with some pretty dramatic consequences. And it's shown us just how fragile this global system of trust can really be.
Let's just rewind to 2011 for a second. The Dutch CA, a company called DigiNotar, was compromised. Attackers issued fake certificates for sites like Google, and these were reportedly used for state-sponsored surveillance. That same year, another CA, Komodo, was breached. And then in 2012, this nasty malware called Flame was discovered using a forged Microsoft certificate to spread completely undetected.
This whole mess revealed the system's Achilles heel. It is only as strong as its weakest link. A compromise at just one out of hundreds of trusted CAs allows an attacker to create perfect forgeries of digital passports, and our browsers would trust them completely. Now, in response, we've created new safeguards, like public certificate transparency logs to make these forgeries easier to spot, but the fundamental design still relies on that same web of trust.
And this is where it really hits home for the average person. Research shows, and this is a direct quote, that most users do not understand what a certificate is. So when they're faced with a security warning, what do? They often just click accept anyway, potentially compromising their own systems.
Okay, so let's put these two worlds side by side one last time. You've got Kerberos, strong, centralized trust, super secure inside its own walls, but it just can't scale. Then you've got PKI, broad, delegated trust. Its strength is its universal scale, but its weakness, well, it's fragile. One bad actor can undermine the whole thing.
This leaves us in a really fascinating and, a slightly unsettling position. We rely on two completely different models of trust. One that is incredibly robust but just can't work on the internet, and one that is absolutely essential for the internet to function but has proven to have some deep structural flaws.
And that brings us to our final question. We built our entire digital world on a system of trust that has these visible and pretty scary cracks in its foundation. So as we move forward, the challenge isn't just about patching those cracks. It's about asking ourselves, what will the next foundation for digital trust actually look like?